Okay, I request you all to confirm. Okay, so let us get started and let's continue with this. I'm just cross-checking on is everything working well or not. Yep, I think everything is hunky-dory. Yep, we can get started. Even before we get started, once again, I am going to take quick 1 minute off and tell you that there is a mind map here, an option called mind map. Please click on that and do a drop down and select AI and deep learning, AI and DL. When you click on that, you go to another mind map. All you need to do is just click on that and you'll be game. All right. So a couple of quick feedbacks that I've received, I wish to clarify. The first feedback was that can you take vision related examples or image related examples, basically? Of course, we will do that. But image related examples does not fit well in all the scenarios for all the concepts. That's not possible. So I'm taking an example which is not just related to people who are working on computer vision and image processing, but which is generic in nature. And the reason why I've used banking example is we all sometime in our life would have taken a loan. Yeah, we all would have taken loan. We all would be using credit cards. So it becomes easy for people to relate, right? If we go very technically, all the other people who are from non-IT background or non-computer science background, they will face a challenge in understanding. So concept should be clear. How does it matter whether we are discussing on image or video? It doesn't really matter. At the end of the day, did we understand the concepts? Wonderful. You can just expand that to any example of your choice. That's number one. Number two, uh, you know what? We have all these algorithms, right? All these neural network algorithms. Out of all these, only only convolution neural network deals with images. So we should not be overweighing our emphasis on only images and videos. The reason being, we have artificial neural network. We can predict the crisis in banking system, the crisis, recessions, macroeconomic values can be forecasted, can be predicted using artificial neural network or multi-layered perceptron. Recurrent neural network, long short-term memory, GRUs, BERT, XLNet, right? Mask RCNN, which is coupled with computer vision, of course, speech recognition system, chatbots, generative adversarial networks, autoencoders, which is used to replicate the market altogether. People invest in the market, Boltzmann machines, reinforcement learning. There are a bunch of other things also. So my suggestion is that while it might look very luring for us to work on images and videos, a lot of amazing use cases are solved using the other algorithms. And the latest fab is reinforcement learning and GANs. People are going crazy behind these. These are doing wonderful jobs, right? So everything is equally important. That is exactly what I wish to tell you. So even if you are feeling that videos and images is the way to go, absolutely no, right? Absolutely no. On a serious note, it's no. Okay, and computer vision and image processing, of course we will spend some time on that. Then we are also going to spend some time on, of course, CNN also. And on the last day, we will see how much we can cover, and the remaining algorithms we will at least theoretically understand those. Okay? Because it's a proper 80-hour training that we provide. These 20 hours will actually at least set a tone, set the context to proceed further. All right. Let me see how many of y'all are there. Still, a lot of people have to join, but that's okay. Let's continue. Always approach AI project, AI business problem from a project management perspective. Do not jump into algorithms, because jumping into algorithms would only mean that you are being very unstructured in approaching the problem. Yeah. Running the machine learning algorithm is only so much. And the research says that understanding the business problem, collecting the data, data cleansing and preparation, etc., will consume 60 to 80% of the time of the project time. Only 20% of the time people spend on actual algorithm. If it's only 20% of the time, then do you think it makes sense to focus on only algorithms? No. Hence, we are giving an overall, you know, view to this. And another thing was one of our other participant was asking, hey, mean imputation, don't you think it is not going to add any big value? Of course, I understand that. But the logic is not to learn imputation. The logic is to understand what imputation means, right? So otherwise, as part of our regular data science training, which lasts for approximately again another 80 hours, assume, we have all these things that we discuss as part of imputation. Okay, we discuss all these things. What do you mean by deletion methods? What are the simple strategies that exist, right? What are the single imputation methods that exist? Mean, median, mode, random, hot regression, KNN. What are the various model-based methods that exist? It's a thorough analysis that we do. The reason why I didn't delve deep into that question is because, yeah, there is only so much that we can do in the allotted time, right? Given the time constraints, what is the best that we can do is the need of the hour. All right, let's proceed further, because people keep asking me this, that I happen to be director of 360DigiTMG as well. So whenever we have discussions with our heads of departments, they keep saying that, do you know what, if I can get 5 more resources, we can do wonders. Then my answer to them is, if there are 5 more resources, then you are not needed. Anyone else can do the job. The fact that you are sitting here is because, given the constraints of resources or given the constraints of budgets, do the best that you can. And that is what is management all about. Given the constraints, do your best. All right, let's proceed further. So we started off by understanding about CRISP-DM, cross industry standard process for data mining, in which we understood the business problem. Once we understand the business problem, you need to record the business objectives and business constraints. Once you're done with this, you have to come up with a project charter. Our students who do internship with us learn end-to-end project management methodology also in executing the projects. Once again, I'm sick of theoretical people, right? Practical data science, practical AI is the need of the hour. That is what industry needs. We cannot keep churning out, students who only have theoretical knowledge. Hence, we would focus on practical stuff. And I'm telling you all, dear faculty members, if any one of you is interested after this training in associating with us in working on any live projects, or if you feel any of the students are bright, if they want to get experience in live projects, we are willing to support. At any given point of time, we'll have 6 to 8 projects, live projects, which will be running. And every trainer that we have, they train only for 20 to 30% of their time. 70 to 80% of their time they work on projects. And that is why our trainers are very unique, because they bring in that practical experience. We don't bank on just theory. Okay. Nevertheless, our theory concepts are extremely good. I mean, I'm unmatched. I'm very proud of that. Okay. So once you're done with understanding the business problem, you collect the data, in which you have data types. We understood about all these data types, and then we understood about primary data sources and secondary data sources. Though the name here says secondary data source, we first go after secondary data source because this is the data collected beforehand. Once you have the data at your disposal, you proceed further with your analysis. However, if you do not have the data needed for your analysis, you go after primary data sources. Okay, next. We have the next step is, once you have the data need not be in a clean format. So what do? You explode the data, you perform feature engineering, you clean the data. All these three steps are overlapping. Then with the clean data, you perform data mining or machine learning, in which we will get into supervised learning. But however, before we get there, we have understood about the machine learning primer. In machine learning primer, we understood that we need to split the data into training, validation, and test. And you build your model on the training data, test the model on the validation data. And then you keep tweaking your hyperparameters until you get the desired accuracy. Once you feel that, hey, these settings are going to give the best results, then you take that model and test on the test data. And testing error is also called as generalization error. Then what do? You compare. You compare the training error and testing error. If both training and testing error are low and close to each other, then it is called as right fit. If the training error is low and if the testing error is high, you call this as overfitting or variance. And to fix this problem, each algorithm has different set of techniques called as regularization techniques, and we are going to learn about those as well. If both training error and testing error are high, then it is called as underfitting or bias. If you're suffering from bias, you need to just get more data. More data, perform better transformation, perform better feature engineering, etc. Then we started off by discussing about how to measure or how to evaluate the performance of the model if your output variable is continuous. If the output variable is continuous, we proceed further with mean error or mean absolute deviation or mean squared error, right? Mean absolute deviation is also called as mean absolute error. Then root mean squared error, mean percentage error, mean absolute percentage error, and correlation. Of course, our book that we are launching has a lot of additional measures, because we want certain things to be more robust. Okay, that's the reason. Anyways, now we also thought that we are going today discuss about how to deal with the model evaluation techniques if the output variable is discrete. Be it two or more than two categories, doesn't matter. You can proceed with confusion matrix, and there are a bunch of these. Okay. But before we proceed with confusion matrix and all that, which is pretty simple and pretty easy, we would discuss about something which is very relevant for AI. And that is nothing but if output variable is discrete, you proceed further with, okay, let me put it here. If output is continuous, all of these. If output is discrete, you go with something called as cross entropy. Okay, and also you have something called as Kalman-Leibler divergence, but we will stick to cross entropy. Even if your output variable is discrete in more than two categories, you go with cross entropy, categorical cross entropy. Here you proceed further with binary cross entropy. Okay. However, even before we proceed further, I have a question for you. Let me ask that question. So here the question is, if the training error is low and testing error is high, then this scenario is called as overfitting or underfitting. Please, can you answer this? Let me see how many of you all get it right. If the training error is low, but testing error is high, then what is this scenario called as? I request everyone to respond. This will make your understanding very clear. Please, I request everyone to respond. Yeah, this scenario, I mean, we can go with majority. Like Kaun Banega Crorepati, right? Something on those lines. Yeah. 67% of y'all are saying that it's overfitting, and yep, that is called as overfitting. Okay. Now, in order to understand cross entropy and binary cross entropy, etc., which is extensively used, I will have to resort to spreadsheet. Okay, and here we are going to first understand on what is information theory 101. If I make a statement such as the sun today, sun rose in the east. Okay, this is a statement that I'm making. Okay, if I make such a statement, what do you think is the probability associated with this? Yeah. Can you all please respond? What is the probability that sun, I'm just saying that today sun rose in the east. What is the probability associated with this event that, I'll write it as event, that sun rises in the east? What is the probability associated with that? Sorry, let me check here. 1, absolutely. Okay, probability is 1. So here, I'll put it as 1. That means it is a certain event. And what is the information contained with this? What is the information contained with this event? What do you think is the information? If news channel starts putting this as a news, saying that today sun rose in the east, what would you say? Oh, is it? Right? So information contained with that is, with this event, is zero. Absolutely, there is no information, and information is measured in bits. So there is zero information with this. On the other side, if I say that there was an earthquake in Hyderabad, here, what is the probability that there'll be an earthquake in Hyderabad? It is very rare, right? Very, very rare. Probably it will be something like, you know, 1 divided by, in how many years? Probably in 20 years. One time you might hear. So 20 years means 365 days. This will be the probability. And how did I arrive at this? Probability is nothing but number of interested events divided by total number of events. Earthquake occurred. Okay, there was an earthquake in Hyderabad yesterday, for example. That's a single event. In how many years do you think earthquake occurs once in Hyderabad? Maybe 20 years. I'm just taking a hypothetical situation because while I was a kid, I heard in news that there was an earthquake, right? So if it's once in every 20 years, then you just multiply it with 365. Very low probability. And think about a news channel. Think about a news channel that if there is going to be an earthquake, then what do you think news channels would do? News channels are going to flash it across because there is a lot of information in it. So the information contained here would be very high. I would say low information, almost 0 bits. Here you'll have very high information. Right? Now, what does this mean? This means that the amount of information contained is proportional to the probability or the rarity of event occurring. If an event occurring is very rare, then information contained would be very high. Right? If information, if that is a very rare event, then information will be very high. So I can write this as information contained in an event is equal to 1 divided by probability of an event. If probability is very low, denominator will be very small. If denominator is very small, overall information content will be higher. If the probability is 1, as in the sun rose in the east, it'll be 1. 1 by 1 is 1, right? 1 by 1 is 1. Simple. But then here, if the probability of earthquake occurring in Hyderabad is 0.0001, 1 divided by 0.0001 would be what? You multiply here with 10,000 and multiply here with 10,000, and then you'd get the answer as 10,000. Such a high information content is available here. And for mathematical ease of calculations, we use I mean, of course, as part of our 80-hour program, we explain all these things on y, log, and all that. We don't have that luxury here. So excuse me for that. So you just take a log. For mathematical ease, just understand that. Now, when I take this probability on the top, log base 2, probability of event, then since you're taking this probability to the top, you put a minus sign. Minus log of probability base 2. That is going to give you information content. Next. That's information content, right? Just remember that information is proportional, inversely proportional to probability. And you can represent that in this way: equation, information of the event, information content in an event is equal to minus log of p base 2. That's the explanation. Okay, at word go, sometimes you might not understand. You might have to watch the video once again to be able to understand this concept better, but that's fine. Whatever max you can absorb in one sitting, please do so. And here, I need to now explain about entropy. Of course, there are other things such as Gini index, pure regions, and all that, but all that aside, let us understand about entropy. And then I'm going to explain about cross entropy. First, let us understand about entropy. Okay. So to calculate entropy of any of these variables, say there are three variables: ball size, ball color, and price. And say you want to predict the output on whether your ball is useful for play or not, whether the ball is useful for play or not. And you have three inputs. Let me first take ball size and see on whether, if I use ball size and then proceed further with decision making on whether it's useful for play or not, how effective this ball size is. So let me put it here. Let me take ball size. Okay, and we're going to look at this. There are two decisions, right? Two class problem. One is yes, another is no. So either it has to be yes, useful for play, or no, not useful for play. And you might ask me, hey, what is this entropy? Entropy is nothing but information content. Already we discussed about information content. It's inversely proportional to probability. We already discussed that. Same thing. Okay. Entropy is also information content. It's expected information content. All right. So you have ball size, useful for play, yes and a no. And when you were to take decision based on ball size, probably you'll say that, okay, less than or equal to 50, I would say it's useful for play. Greater than 50, it is not useful for play. And then if you look at this first one, ball size here is 10. Is 10 less than or equal to 50 or greater than 50? It is less than or equal to 50. Since it's less than or equal to 50, here you're going to predict that it is y. Then you compare it with the actual value. Actual value is also yes. So is there a match here? Yes, there is a match. Right prediction. Next let's take this 10. Sorry, 1. Is one greater than 50 or less than or equal to 50? One is less than or equal to 50. So what does your model predict? Your model will predict that it is useful for play. Try to compare it with the actual value. Actually, it says yes. So there is a match. Next, let's go to this third row. Value is 50. Is 50 greater than 50 or less than or equal to 50? It's less than or equal to 50. So the predicted value will be yes. And what is the actual value here? Yes. Oh, there is again a match. Then let's go to the fourth row. Here the value is 100. Is 100 less than or equal to 50 or greater than 50? It's greater than 50. Right? This 100 is greater than 50. So the predicted value says no. And what does your actual value say? No. So no equal to no. Is there a match? Yes. And fifth one here, the value is 1000. Is 1000 greater than 50? Yes, it's greater than 50. So your predicted value will be no. And what does your actual value here say? No. Wonderful. Everything is a match. So when you choose ball size as your variable for decision making, there is a perfect match. Now, how do I calculate entropy? Entropy is written as in this way, minus summation of I equal to 1 until n. N is how many classes? How many classes do you have? Yes and a no. So it's a two class problem. Probability of xi into log of probability of xi base b. How do you write it? You substitute I equal to 1 in this. So it'll become minus p of x1 into log of p of x1 base 2 minus I equal to 2 is p of x2 into log of p of x2 base 2. Why do we have a minus sign is something that we just explained, right? We just understood. What did we understand? That information contained in an event is 1 divided by probability of the event. And we take a log for simplicity purpose, math simplicity. If I take p on the top, it becomes minus log of probability base 2. And an extension of this is information content. An extension of this is called as entropy. There's a formula for entropy. Entropy is nothing but expected information content. There's something again. Okay, let me not get into that math. So that's all part of our data science, and we get into the depth of math and all that. We don't have that luxury here because it's for 20 hours. Okay. So here, how do you calculate? Let me erase these. And let me also choose help so that it's clear. All right. Now P of x1 is probability of x1. I mean, yes, probability of yes. And when you calculate probability or entropy, first you need to calculate entropy towards the left side. This is called as left side entropy, this part. Okay, so probability of entropy towards the left side is having only 3 entries. If you look at this decision, less than or equal to 50, and if you look at the data set, it will consider only until here, less than or equal to 50, these 3 entries. So you have 3. 3 out of 3 are yes. So it will be 1. Probability of x2 is how many times do you have no? How many times do you have no here? You do not have no. So it's 0 out of 3 times. 0 out of 3 times you have no. So this is 0. Now when you substitute those here, it'll become minus 1 into, because p of x1 is 1, into log of 1 base 2 minus 0 into log of 0 base 2. Log 1 is 0. Minus 1 into minus 1 into 0 is 0. Minus 0 into something is 0. So overall you get 0. So entropy towards the left side is 0. Entropy left is 0. Let me also delete the other things, irrelevant things which are not needed. Might be confusing otherwise. Let me delete this and this. Okay, done. Okay, now it won't be confusing for you all. Entropy towards the left side is 0. On similar lines, let us calculate entropy towards the right hand side. Okay, so entropy to the right side, if you were to calculate, I'm speaking about this portion, which is this rule, greater than 50. Greater than 50, if you look at ball size, we have only these two entries, which are greater than 50. So here, probability of x1 is equal to probability of yes, which is equal to, how many times do you have yes here? 0 times. 0 out of 2 times. So this is 0. Probability of x2 is nothing but probability of no. How many times do you have no? 2 times out of 2. 2 by 2 is 1. So again you substitute p of x1 is 0. So minus 0 into log of 0 base 2 minus 1 into log of 1 base 2. Log 1 is 0. 0 into 0, 0 minus 1 into 0 is 0. So overall you get 0. So entropy towards the right is also 0. And when you add this, you get 0. So overall, when you use ball size, you're getting 0. What do you mean by 0? There is no error. It is completely pure. There is no error. Entropy is error. There is no error. If there is no error, it is completely pure basically. And you know what? Purity, how pure or how impure your data is, right, is given using 1 minus entropy. And if entropy is 0, 1 minus 0 is 1. So that means there is 100% purity if you choose ball size. This is fine. Now what? Oh my God. Let me go back. Yeah. Now what we shall do is we will choose not the ball size, but let me choose another thing. Let's use price. Okay. And let's see how it works. If we choose price, will we have any error or not? Let us understand. Price. Price, if you want to come up with, it's a 2-class problem, yes or a no. Depending on the price, will the ball be useful for play or not? Yes or a no. Okay, now here, if you want the rule, maybe the best rule that you can come up with is less than or equal to 5 means yes. Remember, generic rules, not specific rules, and greater than 5. Now let's see how it works out to be. So here, if look at this first value, it is 5. Is 5 less than or equal to 5? Equal to 5. Means what is the predicted value going to be? Yes. And what does your actual value say? That also says yes. So there is a match. And let's go to the second row. You have 1. Is 1 less than or equal to 5? Yes. So the predicted value will be yes. And what is your actual value? Yes. Third entry is 5. Is 5 less than or equal to 5? Yeah, it's less than or equal to 5. So predicted value is yes. And what does your actual value say? Yes. And again, less than or equal to 5. This one, if you look at this, is less than or equal to 5. Predicted value is yes. But when you look at the actual value, it is no. So there is a mismatch. Okay, there seems to be a mismatch. So that's with your left hand side. On right hand side, if you go to this, it's greater than 5. Since it's 10 is greater than 5, predicted value will be no. And what does your actual value say? That also says no. There is a match. Wonderful. Now, if we were to calculate entropy towards the left side, what would that be? Let's see. I am not erasing the formula because writing it always does not make sense. So here, if you look at the left hand side, if you want entropy left, less than or equal to 5. Okay, less than or equal to 5 means all of these values. If you look at these values, they are less than or equal to 5. And you have 4 entries. Probability of x1 is equal to probability of yes. How many do you see yes? 3 out of 4. And probability of x2 is equal to probability of no. How many no do you have? 1 out of 4. So it's 1 by 4. Then how do you calculate this? It is minus 3 by 4 into log of 3 by 4 base 2 minus, this is 1 by 4, 1 by 4 into log of 1 by 4 base 2. When you solve it, you'll get some number. Let me solve it quickly here. Entropy left is equal to minus 3 by 4 into log of log of 3 by 4 comma base 2 minus 1 by 4 into log of 1 by 4 base 2. When you solve it, you get 0.81128. That's entropy towards the left side. Okay. Now, if you were to calculate entropy towards the right hand side, that is greater than 5. Greater than 5 is only 10. So you have only one entry here. So probability of yes. Do you have yes here? No, I do not have. So 0 out of 1 entry is yes. And for no, 1 out of 1 entry is no. So here you get 0, here you get 1. So how do you write it? 0 into log of 0 base 2 minus 1 into log of 1 base 2. When you solve it, you get 0. So entropy towards the right is 0. And what is the overall entropy? You can add them. Of course, you take the weight and then add, but forget about that. Yeah, you have entropy. Means what? You have some error. Entropy means error. So you have some error. Okay. And how about purity? How pure is it? Purity is equal to 1 minus entropy. You can say 1 minus some weighted average of this, you get entropy. Solve. Okay, next. If this is entropy, then what is cross entropy? Say you have images. given a specific image, say this is an image of an elephant, okay, and say you have a 4-class problem, meaning by looking at the image, you need to classify on whether the image is that of an elephant or a tiger or a lion or maybe a cat in that way. This is the actual data you have. If this is elephant, you put a 1 against elephant. That is 100% probability that this is elephant, because this is the actual data. Someone is looking at this image and saying this is an elephant. So you put a 1 and 0 here. Very important, friends. Please pay attention on why we have put it in this way. This is called as one hot encoding, by the way. Only in one of the places you have 1, rest all are zeros. One hot encoding. I think we discussed this. Okay. Next. Say you are supplying this image to your algorithm that you built. Whatever neural network algorithm that you built. And what will happen? You'll get the predicted values. Predicted values. And here you have same elephant, tiger, lion, and cat. Elephant, tiger, lion, cat. Your model might predict that. Do you know what? There is 0.7% probability that it is an elephant, 0.15 probability that it is a tiger, 0.1 probability that it is lion, and 0.05% probability that it is cat. When you add all these probability values, you get 1. Of course, sum of all the probability values is equal to 1. We all know that. Now, how do I calculate entropy? Say I give a notation P here, I give a notation Q. So cross entropy is given as summation of I equal to 1 until n minus. Why minus? Again, I will write for you. Again, I will write for you. Information of an event is how much information is contained in an event is related to how rare that event is. If someone says there's an earthquake in Hyderabad, there'll be high information in it. On news channels, it'll be flashing. Flash news, right? TV9, TV5, whatever, all the TVs will be behind that. So that means there is a lot of information in that. That means if you do 1 by probability, you get this. And why do you take a log? For mathematical ease. If you take probability on the top, it becomes minus log of probability of an event, base 2. You might ask me, why base 2? Why not base 10? Why not base natural log? Why not base e, so on and so forth? All that is out of scope. Okay. Yeah, of course, as part of our main program, we explain as part of mathematical foundations, but we'll not get into that depth here. Okay. So that's why we are having the same thing. It's P into log of Q, simple. So how many classes do you have? 4 classes. So you write it as minus summation of I equal to 1 until 4, P into log of Q. Or you can say Pi into log of Qi. If you substitute I equal to 1, it becomes P1 into log of Q1 minus I equal to 2. If you substitute, it becomes P2 into log of Q2. Of course, base 2 will be there. Minus P3 into log of Q3 base 2 minus P4 into log of log of Q4 base 2. Now 1 into this minus 1 into log of 0.7 base 2 minus 0 into this will become 0. 0 into log of this will become 0. 0 into log of this will become 0. So you'll be left out with minus 1 into log of 0.7 base 2. When you solve this, you get the cross entropy. Okay, when you solve this, you get cross entropy for one image. Okay, for one image, you can have thousands of images, right? Here you're getting cross entropy for a single image. When you solve this, you get a single number. Let me solve it. Let me do it end to end. Yeah. So it'll become log of 0.7 base 2 is minus 1 into minus 0.51457. When you multiply it, it'll become 0.51457. This is your cross entropy. That's your error for one image. Okay. Now here is where I want you all to focus on what we are going to discuss. Okay. You have three things that we need to understand, or we have three things to understand. One is called as loss function. If you calculate cross entropy or mean error, whatever be it, for one image, and say you have 1,000 images, all the 1,000 images. For each image, the cross entropy that you calculate here, cross entropy, or okay, if you have two classes, is there a lion or a tiger? Binary. Categorical cross entropy means you have multiple classes. Like the example that we have seen, elephant, tiger, lion, you have multiple classes. Okay. If you calculate cross entropy for a single image, it is called as loss function. Here also it is called as loss function. For third image, when you calculate cross entropy or anything, cross entropy, binary cross entropy, categorical cross entropy, mean error, mean squared error, whatever you calculate, it will be called as loss function. You take all these loss functions and combine all these loss functions, you'll get some numbers 0.2, 0.5, like what we calculated, right? Previously for our example, you'll get all those numbers. If you take average of all those numbers or in some way you combine those, it is called as cost function. It is called as cost function, right? Cause, okay, 1 second, friends, sorry. Okay, here, loss function is for each and every entry, and loss function, loss function is for each and every entry, and cost function is for all the entries put together. So all the images, loss functions put together and combine them, it's called as cost function. People get confused. Interchangeably, they keep using. And this is a perfect question that we ask in interviews to determine whether people actually understand the underlying concept or not. If you're interchangeably using all these terms, then we know that this guy doesn't have clarity. Okay, next. One more thing I need to explain quickly, and that is error function. So there are three things: error function, loss function, and cost function. Okay, error function, when it comes to output variable continuous, would be what? It would be your mean error, mean absolute error, or absolute deviation, mean squared error. All these are error functions. Do you know what loss functions are also the same when it comes to output variable continuous? Mean squared error, all these. Cost function also will be the same. The only thing is all these individual rows loss function is being combined together. Okay. But if your output variable is discrete, okay, error function is calculated using confusion matrix or cross table Okay. Loss function here would be if it's discrete in two categories. It's cross table or contingency table, confusion matrix, many names are there. And loss function would be binary cross entropy. And here also it is called as binary cross entropy. If your output variable is discrete, this table you need to remember. As soon as we take quick 10 minutes break and come back, we will be doing some kind of quick poll questions around this. If your output variable is discrete, and if you have more than two categories, it is called as, again you use the same thing, confusion matrix or cross table. Confusion matrix or cross table. And loss function would be categorical cross entropy. And here also the cost function is categorical cross entropy. So output variable continuous, output variable discrete, output variable discrete in more than two categories. Error function, loss function, cost function. This information should be very clear, like the back of your hand. Okay. So let's do one thing. I think we have covered a lot of ground in terms of we understood on what is information content, and we understood that information content is equivalent to rarity, how rare an event is, which is given using 1 by probability of the event. We take log for mathematical simplicity, and if you take probability on the top, you write it as base to probability of event. This is information content. And what is entropy? Entropy is loss, right? Error, impurity in some sense. How impure your data is. This is given using minus summation of I equal to 1 until n pi into log of pi base 2. That's same log of this. Why do you have probability into this? For that you have to go back and check what is a formula of expected value or mean, which is summation of x into probability of x. I mean, if you don't know this, just go and do some quick read on this. Okay, that's why you get this is like x, this is like probability of x. If you do not understand that, forget it. Okay, I do not intend to get into the depth and confuse you more, but then yeah, these are the things that you need to remember from this. I mean, the same thing, you're just terming it as cross entropy because you're trying to compare what? Predicted values and actual values. That's it. That's why cross entropy. If you have two categories, you use binary cross entropy. If you have more than two categories, you use categorical cross entropy. That's it. This is all we discussed. And we have also discussed one more thing on what is the difference between loss function, cost function, and error function. Error function is used to evaluate your model on how accurate is your model basically. And loss function or cost function are used to are used for optimization purpose. Hey, what is this optimization? You're bringing in a new concept now. Hold on, friends. We will do mathematical foundations to understand optimization. Okay. Why are we doing all these things? Because when we run our first algorithm using Python, you should not be confused when I use binary cross entropy or categorical cross entropy. You should not be confused when I use mean squared error, mean absolute error, etc. You should not be confused. When I say accuracy is how I'm going to evaluate the model, and loss function would be binary, you should not be confused. So we will first ensure that we strike off each and everything that we are going to use in our neural network algorithm, and then we'll get started with the first algorithm. Okay. All right. Now, let's take a quick break, and we are going to get started at 6:10. Let's take a quick break and come back. Worth taking the break. Okay, let's continue. Yep, Kranti, I think I've explained. Yeah, sure. Let me do that right away. And it's break time, and people might take just a minute to come in, right? So quickly again, the links are already posted here, but then let me post once again. I just need to check yeah, here it is. So this is the YouTube link. We have day 1, day 2, and day 3, which is made available. And today is day 4. So you can get access to all of these. Once again, needless to say that you need to subscribe and click on the notification icon to be able to view all the future, um, you know, videos. So that's the YouTube thing. And oops, I think this is my LinkedIn profile. Sorry. If at all you want to connect with me, it's there here. I thought that's where we posted the quiz. Here it is. And if you want to access quiz, simple, very simple. Go to 360digitmg.com, scroll down completely, and mhm, and click on this LinkedIn icon that you see, and follow. Please do not forget to follow us. Yeah, follow to be able to get all the notifications. And then we today also posted our manufacturing on automotive analytics program that we have launched. But and we have a lot of mind maps and a lot of sessions happening, a lot of interesting articles being posted from the likes of MIT, etc. And this is a quiz question for day 3. Amazing, 55 people have responded. I'm extremely happy for that. But if everyone responds, that would be even better, because it's a way to test yourself. It would hardly take 5-10 minutes. Take out your time, right? This is the link, and if you want access to this, let me copy it and quickly paste it here. And yep, our people have already done that. Facebook in this. Go enjoy with that. Okay. So let us now proceed further and understand more. So to give you a high level picture once again, you need to understand the business problem, collect the data, clean the data, and perform machine learning. Even before we perform machine learning, we need to understand machine learning primer, means basics of machine learning, how it works and all that high level, before we start the first algorithm. And here we have certain model evaluation techniques, and we have cost function and loss function. There are two things. There are two things basically. One is model evaluation techniques, and one is optimization measures. Model evaluation measures. Another is optimization measures. Let me put it in this way so that it's easier for you to understand. Model evaluation means after you build your model, you have to obviously tell to your customer and how accurate your model is, right? You have to speak about your model accuracy. If I say model is 93% accurate, then what is the error? Error would be 7%, because when you add these two, you should get 100%. How do you evaluate or calculate the accuracy? It depends on whether your output variable is continuous or whether your output variable is discrete in two categories. Two categories means does a patient have cancer or not? Two binary, two categories. And whether your output variable is discrete in more than two categories. It depends on these things. If your output variable is continuous, you can use something called as mean error or mean absolute error or mean square error, root mean squared error, okay, root mean squared error or mean percentage error or mean absolute percentage error. You can use that. When it comes to your output variable discrete in two categories, you use something called as categorical cross entropy. And when your output variable is discrete in more than two categories, you use something called as, sorry. We use two categories, means you use binary. Bi means two. Binary cross entropy. Greater than two means categorical cross entropy. Ha. What am I thinking? Extremely sorry, friends. I was thinking about, I have this habit, suddenly I keep training and suddenly my brain will be in US. It will be discussing, I'll be thinking about projects, the escalations going on, so on and so forth. Excuse me. I mean, you have to excuse me for this. Okay. Oh, let me come back to normal. Let me not think anything. All right. Okay. There are two things: model evaluation techniques and optimization measures. Okay. And how do you evaluate your model on whether your model is good or bad? Using accuracy. And you know that accuracy plus error is equal to 100%. If your output variable is continuous, you can either use error or accuracy. Here we are using error, mean error or mean absolute error, all of these. If your output variable is discrete in two categories, you use something called as confusion matrix, which is also called as cross table. What is it we will learn? What is it we will learn? We haven't discussed this yet. Okay. If your output variable is discrete in more than two categories, still you use confusion matrix or cross table. Back to our discussion here, optimization. Why do we use optimization measures? Where do we use it? We will come to that. But for now, let us just understand about the terminologies. Optimization measures are used to reduce the error. If mean error or mean absolute error, whatever you use it, your objective is to reduce that. And if your output variable is continuous, yeah, if your output variable is continuous, you still use mean error or mean absolute error, mean squared error, root mean squared error, mean percentage error, etc. If your output variable is discrete in two categories, then you use something called as binary cross entropy. Binary cross entropy. If you have an output variable discrete in more than two categories, then you use categorical cross entropy. Okay, you have categorical cross entropy. Now, you have binary cross entropy, categorical cross entropy, all of these things. And then within this, I've also explained you about another thing, which is loss function versus cost function. Loss function is one of these, either mean error or these are binary cross entropy or categorical cross entropy for every single row of your data set, right? If it's for every single record or row. If you combine for all the rows, all these loss functions, then it becomes cost function. Just the term, just the name changes from loss to cost. Loss is for every row, cost is for the entire data set. It is for entire data set. So you have loss function, cost function, and then you have error function. These are called as error functions, accuracy or error functions, right? So let me write it that way. So error functions are used to evaluate the model, and you have loss function and cost function. Loss is for a single record, cost is for the entire data set. Okay, next. Fine. So now can we move on? Let's move on and understand confusion matrix and cross table. Let us understand these two. To understand that, I would take you guys to or let me do one thing. Let me write it down here and try to explain. For that, you have to just give me a minute, because let me see if I can pull up the right document that I have. Just give me a minute. Just give me a minute while I pull up the right document here. And just a minute, I'm trying to pull up that. And if I cannot pull up, I just pause my screen. If I cannot pull up that, then we'll look at something else. Just give me a minute. I think I do not have the document with me, which I can share and explain with you all. Nevertheless, if that is not there, that shouldn't be a problem. I can anyways help you guys. Okay, that's not there. So let's do it in this way. I would take an example of okay, two class problem, actual class, and say you have the predicted values here. Say we are dealing with a two class problem. What is a two class problem? Does a patient have COVID positive symptoms or COVID negative? Okay, does a person have COVID positive or COVID negative? And a few things that you need to understand here is that you'll have two classes. One is positive, one is negative. Positive means person has COVID positive, has disease. If someone has disease, it is positive. If someone does not have a disease, then it is negative. Yeah. True means correct prediction. False means incorrect prediction. True means correct prediction. False means incorrect prediction. When I say true positive, what does that mean? You have correctly predicted the positive case. That means actually patient has COVID-19 positive. You also predicted that the person has positive, right? You also predict that person is COVID positive. What if I say true negative? True negative means true means correct. Correctly you have predicted which case? Negative case, which is no disease. So actually patient does not have disease. You also predicted that person doesn't have disease. Both are COVID negative. Correctly you predicted the negative case. Wonderful. Next, when I say false positive, what does that mean? You have incorrectly predicted that patient has disease. False positive, right? You have incorrectly predicted that patient has disease. Patient actually doesn't have disease, but you predicted that patient has disease. That is false positive. And then you have false negative. False negative means false means incorrect. Negative means no disease. You have incorrectly predicted that patient does not have a disease. Actually, patient has disease, but you predicted that patient does not have disease. That's false negative. By looking at this, if you were to calculate accuracy, how would you do that? Accuracy is nothing but true. True means accuracy, right? So true positive plus true negative. How many times did you correctly predict? True means correct. How many times did you correctly predict out of overall predictions? How many times did you correctly predict out of overall predictions? That's going to give you accuracy. True positive plus false positive plus false negative plus true negative. Job done. If you want to calculate the error, how do you calculate the error? Error is what? Incorrect predictions. Incorrect means false. So look at how many times you have incorrectly predicted. That is false positive plus false negative divided by overall predictions, which is true positive plus false positive plus false negative plus true negative. So on one side you have accuracy, on another side you have error. Okay, so you have true positive, true negative, and false positive, false negative. This is accuracy and this is error. Okay. This is used to evaluate your model performance. Okay, model evaluation technique. This is a two-class problem, right? You have COVID positive, COVID negative. That's a two-class problem. But then you can have multi-class problem also. For example, I think I have that specific image. Not sure where it goes and saves itself, but let me see if I can get it from the pictures. Saved pictures or maybe screenshots. No, or maybe on desktop. Not sure where I've actually saved it. That's okay. Otherwise, it should be there in one of the Excel sheets. If it's not there, I'll quickly type it. It doesn't take a lot of time. Let me see if I can open that. I keep typing these kind of things whenever I find free time. That is what I do. And okay, no worries. I'll type it. For that's my IIT ID coming up. Anyways, so here multi-class problem. I'll quickly tell you. Say, I mean, you can put it in any way. Say you have an actual class and you have the predicted class. And say you have the details here, such as is the person in the image, okay, or in the video. This is called as say video activity recognition problem. What is the person doing in the video? That is what we are interested in. Assume. So in the video, you want to check whether a person is bending or jumping, or is a person running, or is a person skipping, or is a person walking. Say you have a 5-class problem that you're trying to address. And for predicted class also, you'll have those. Like, is a person bending or jumping or running or skipping or walking? You know what? A quick help. You copy this, insert, okay, and here when you want to paste it, you just say transpose, right? Just in case you don't want to type. That's a small gimmick, gimmick rather. Okay. So here, say 100 out of 100 people have been correctly classified, meaning you predicted for 100 people that they were bending. Actually, they were bending in the video exercise. Jumping also say it was 100. 100 out of 100. Let me select this. Okay, next. For running, probably you got only 80. What about remaining 20? Remaining 20, maybe you classified as if those people were skipping, 20 people. Yeah. Then for skipping, maybe you again got 100. And for walking, maybe accuracy was 90. That means for another 10, it predicted that person was uh, actually jumping. Uh, right. So now let me explain this. If you look at this diagonal that you see here is a right prediction. This is a right prediction, the diagonal elements. Okay. 100 out of 100 bending, accurate. Are there any errors? No. 100 out of 100 are jumping. Do you have any errors? No. 80 out of 100 running. You predicted running, actually it is running, but 20 have been misclassified. So anything which falls on this side or this side of this diagonal would be called as misclassifications. Misclassification entries. These are misclassified values are off diagonal. Right? Correct classifications are on the diagonal. Correct classifications are around the diagonal. Now, so you have 20, right, which are misclassified. Those 20 can also be listed here. It is a mirror image. If you cut along the diagonal, it's a mirror image. For example, you predicted as skipping, but actually it was running, right? Here also it can come up, right, as 20. Basically it's kind of a mirror image, but just not to confuse you guys, I'll remove it from here. And this 10, right? So let's put it as you predicted as walking, but the person was actually jumping, kind of, right? Another 10. All right. So anything which you see along this diagonal, let me give it a different color, is a right prediction. Anything which is off diagonal is your wrong prediction. So this is multi-class. For multi-class, this is what you do. Okay, enough of machine learning primer and all that. Now let us get into mathematical foundations. Once you understand the mathematical foundations, we would get into deep learning primer, and from here on the actual journey starts. Until now, didn't we start the journey? No, we started, but then we'll understand even better. Before that, I have few questions to be asked. Uh, yes, you can Vidyasagar. We'll get there slowly and steadily. We'll get there. Okay, question to you all. If output variable is continuous, then what is the model evaluation technique we use? Do we use cross entropy or do you use mean error? But let me put mean absolute error. Yep. Please, can you answer this? Wonderful, wonderful, amazing. Okay, that's a very good question. Very good response that I've received. Next thing is, if output variable is discrete in more than two categories, not two, more than two categories, then do you go with binary cross entropy or do you go with mean squared error? Or do you go with categorical cross entropy? Let's see who would get it right. Yep, go for it. More than two categories, my dear friends, not two, more than two. You go with categorical cross entropy. 78, 79, 80% of you all approximately are getting it right. Wonderful. Wonderful. Okay, next question is, if output variable is categorical in two categories, then which model okay, then what do we use? Do we use binary cross entropy or categorical cross entropy? Yep, can you all answer this? I didn't publish, sorry, my bad, I didn't publish it. Yep, there you go. If these things are clear, no one is going to stop you from learning any algorithm, because be it RNN, LSTM, GRU, CNN, or ANN, or MLP, all these would be used there. So it's like you're clearing off your, first level of doubts. The next, what is the difference between loss function and cost function? Loss function is for entire data set and cost function is for single record, or is loss function for a single record and cost function is for entire data set. Yep, let's see. Yep, please can you answer this? Wonderful. I'm so very happy. 86. Let me give a minute for everyone to respond. Okay, wonderful. And one last thing. What do we use error function for? And what do we use cost function for? Error function is used for optimization and or is error function is used for evaluation and cost function is used for model optimization. Let's see. Right? Wonderful. Error function is used for model evaluation and cost function is used for model optimization. Slowly we are getting some clarity now. We are just, kind of, we are passing the first standard now. We will then move into the second standard. All right. All right, wonderful. I think approximately 80% of y'all are getting it right. That is a proof that things are going fine. Next, I'm wondering on, would I have time and energy, not energy, would we have time to complete mathematical foundations if we start? I don't think so. So what I shall do is, let's pick up something else and try to firm up our understanding. Okay, let me explain about optimization at a high level. What happens in neural network is that neural network is based on a concept called as optimization. Okay, it is called as optimization. It is going to depend on something called as optimization. What happens here is you'll have error on the y-axis and you'll have something called as weights on the x-axis. For now, just assume that I'm setting up the context on y-axis you'll have error. Error means cost function or loss function. Okay. This error surface would be something like this. It'll be like that. Random, very random. If your weights are randomly initialized here, your weights can get initialized in any way. In neural network, they are first randomly initialized. If they're randomly initialized here, then your error will be so much. But then this optimization, what it does is it will try to optimize your error. What do you want? More error or less error? You want less error. So optimization would be minimize. So it would apply minimization on it. So your error has to be minimized. That means you have to go down. You have to come down the slope because you want the minimum error. So what happens is your weights are updated now. Your weights are updated from say 1 to 2, just as an example. So what will happen to your error? Error also will come down. And the error corresponding to this is error 1, this is error 2. Then you update the weights once again and you have here. So there we go. And here is the error. And then again you update your weights and your error will be again reduced. And now when you update your weights, what will happen to your error? It will start increasing. So it decreased until here, then it will start increasing. The point where your error starts increasing, your model stops there. And your model says that, okay, this is the right weight at which we are getting the minimum error possible. This is the concept of optimization. Okay. Let me now give you a brief of mathematical foundation. Uh, Friends, people who have registered, you will be getting learning management system access next week. Now I'm showing the slides, right? Whatever slides I'm showing, those slides would be made available to you on the learning management system for the next 3 months. You cannot download it, but you can read it. Okay, so let's get started with mathematical foundations, which is extremely pivotal for understanding your uh, deep learning concepts. We will understand about optimization, derivatives, and gradient descent optimization. These are the 3 things that we are going to understand. Okay. And here we go. We use optimization to solve a lot of problems, such as minimizing the travel time, maximizing the code coverage, minimizing the downtime, maximizing the user satisfaction. All these are examples of either minimizing something or maximizing something else, right? It's minimize or maximize. Then say there is a function called as profit is equal to revenue minus expense. Very toy example is what I've taken here. Profit is equal to revenue minus expense is from the business perspective. From the technical perspective, what you would do is you would write it in this way. Okay, so function profit is equal to function of revenue and expense. If I say revenue is x1, expense is x2, then revenue minus expense would be x1 minus x2. Okay, and a few terminologies that you need to remember is that rate of change is also called as derivative. Derivative is also called as slope, and slope is also called as gradient. Rate of change is also called as derivative, which is also called as slope, which is also called as gradient. And here is a function to calculate the rate of change. This is a typical GMAT question or any entrance exam question, right? I have so much money. Okay, if my profits increase by so much, what is the rate at which things change? Those kind of questions. So, anyways, that aside, say you formulated your business problem into a mathematical equation, and here is your mathematical equation. F of x is equal to 4x minus x square. Okay, if you substitute x equal to 2 in this equation, x equal to 2 here, what would it become? F of 2 is equal to 4 into 2 minus 2 square, which is nothing but 8 minus 4, and you get 4. If I substitute x equal to 3 in this equation, f of 3 is equal to 4 into 3 minus 3 square, which is 12 minus 9, and you get 3. Now, when I want to find out the rate of change, if you want to find the rate of change, what is it that you're trying to find? You're taking your y-axis values and you have your x-axis values. You have 1, 2, 3, 4, 5 in that way, and you have 1, 2, 3, 4 in that way values. And if x equal to 2, if x is equal to 2, y is equal to 4. So you plot it. 2, if x is 2, y is 4. This point is x is 2, y is 4. And if x equal to 3, what is happening to y? When you substitute that 3 here, you're getting 3. So here you have 3, and here also you have 3. So you have 3 comma 3. And what is happening to the slope? Slope is reducing. Rate of change is reducing. If the x value increases by 1 unit, y value decreases by 1 unit. That's rate of change or derivative or slope or gradient. All mean the same. Now, if I were to substitute here, f of x plus delta x, meaning x is moving from x to from 2 to 3. Delta x is 1. It's moving from 2 to 3, right? 2 to 3, the increase is how much? From 2 to 3, the delta x increases only 1. So that's x plus delta x. That's f of 3. So it's f of 3 minus f of 2 divided by delta x is 1. So f of 3 is 3 and f of 2 is 4 divided by 1, which is equal to minus 1. Minus 1 means what? It is slope is reducing by minus 1. Is it reducing by minus 1? Let's see. I increased x from 2 to 3 and y reduced from 4 to 3. It reduced by 1. Wonderful. This is called as rate of change or derivative or slope or gradient. This is what we need to understand to be able to proceed further and learn about data optimization. Okay. So, my dear people, whoever has registered with task, right? uh, the details are shared with us already, and we would be giving them learning management system access. People who have not registered, I am really not sure. I will check with task and I shall get back to you guys. Okay, so bear with me on that front, please. All right. So that's what we had for today's discussion. So we discussed a lot of stuff today. Okay, let me once again quickly wrap it up. And we have discussed good bit about what is the difference between error function, then loss function, and cost function. And we also discussed that this loss function and cost function are used for optimization purpose. And tomorrow, once we discuss about optimization completely, this math foundation, it'll become crystal clear. Trust me on that. If it's not clear today, tomorrow by end of business, I will ensure that I hammer these concepts into your brain. And for error functions, these are used for model evaluation purpose. And it changes based on whether you have your output variable continuous or whether your output variable is discrete in two categories, or whether your output variable is discrete in more than two categories. The reason why I keep doing recap is because at one go it is difficult to understand this, right? I understand. I was once a student. I would feel very bad if my professor would just teach it for the sake of, right? So I don't want to fall into that category. Okay, here mean error, mean absolute error, so on and so forth can be used. The same mean error, the same mean absolute error can be used here also. The same mean error, mean absolute error can be used here also. All right, loss and cost are both the same. Just that this is for a single row, this is for entire data set. Categorical, oh, error function is, again, I was about to make the same mistake. Confusion matrix. And we have discussed about confusion matrix. And we also know another name for this, which is cross table. And here loss function would be binary cross entropy. Here also it's the same, binary cross entropy. Then here, same thing, confusion matrix or cross table, but here you change it to categorical cross entropy. And categorical cross entropy is the same for loss or cost. Yeah. So to a very great extent, we got a better understanding of all these things. Tomorrow, we will discuss about this portion called optimization, because we just completed evaluation thing already. Optimization, and then you'll understand things better. Sure. So I shall stop here, and there is a form which is given, friends, attendance form. I would request you to give your attendance, and people who are asking us to add you to the WhatsApp group or to the sessions, I'll let you know. And one more thing, I just found out one thing, that there was someone, I was just notified by our team that there was a guy who was actually posting about spam and all that. Some unknown number. Let me see if that's there here. Okay, it's not there. Someone was trying to spam and he told that, okay, just dislike it as many as possible. So that's the reason why you're seeing here this. These spamsters have only one job, just destroy the image of the company. That's fine. Let them do whatever they want. or we will stick out our neck, and then we will try our best. And I request you all to please up like it, so that this doesn't counter that. These spamsters will be there everywhere. Yeah. Thank you all so much, friends. And yeah, we will connect again tomorrow. No, it will be different for each and every day. The attendance will be different for each and every day. Missed attendance is missed, I think, because task we are sharing with them on a daily basis. Yeah, it will be provided, Sadi Kumar. But again, let us not be theoretical, right? So practically we do it. So I write a lot on the screen. This is my style of teaching. It's a different style. I don't go by slides, but whatever slides we have, we will post them on learning management system. On the last day, we will let you know, Kranti, about the live projects. Okay. LMS stands for learning management system. Yep. Thank you all. Sure. We shall do that. They are there on our YouTube channel a lot. Thank you all, friends. Thank you.